Welcome back. This is part 2 for the 8.2 notes. We're going to pick up where we left off and move on to example number 4. So if we look at example 4, we want to find the equation of the graph that's passing through the point 0, 2 and has a slope y prime equals 2y over 3x. So again, we want the equation of the graph. So it passes through a point, it has a given slope. We're going to go ahead and solve that differential equation. So let's think about what's going on here. All right, so y prime, well, pause the video, give it a shot on your own. And then y prime, we can, again, rewrite it as dy dx equals 2y over 3x. And we want to get the y's to the left and the x's to the right. Now, one thing I would recommend is, try to move just the y to the left if you can. All right, and I'll tell you what I mean by that. So in this particular case, I can move the y over and think of this as 1 over y dy. And then on the right side, we end up with 2 over 3x dx. And what I'm trying to do is I'm trying to keep that side with y as simple as I can. All right, and in doing so, you've got the y's on the left, the x's on the right, and then we can go ahead and take the integral on both sides. So on the left side, the integral of 1 over y dy, that's the absolute or natural log of the absolute value of y. All right, and then on the right side, that 2/3 can be taken out in front of the integral, which I didn't show. But then we just have 1 over x. And the integral of 1 over x is going to be the natural log of the absolute value of x plus c. So we end up with this situation. And now at that point, we can go ahead and take e of both sides to isolate y. Y is going to equal. Now this is e to the 2/3 ln absolute value of x plus c. Now you might remember from before a couple things. That c can come out in front as the constant, okay? Because you could write it as e to the 2/3 ln of x times e to the c. But e to the c is just a constant because we haven't figured it out yet. So if we do that, we've got y equals c e to the 2/3 ln absolute value of x. Again, in this case, the absolute value is not necessary in this case, all right, because the output of e is always positive. And then in this, what we can also do here is this 2/3 can become the exponent. So if we kept going, let me get a different color. So if we kept going with that, we would get, CE ln of x to the 2/3. All right, and then you have that e and that ln, which is going to allow you to cancel them out, giving us y equals cx to the 2/3 power. Now, that right there is going to become, that's your general solution, but we want to find the equation of the graph passing through the point A2. So we're going to go ahead now and take that point and plug it in order to find c. So 2 is equal to c times 8 to the 2/3 power. Sorry guys, I don't know why that stuff just jumped down there. Let me see if I can move it up. See if it's going to let me do that. All right. But we have, 2 equals c8 to the 2/3 power. We need to simplify that down. So let's think about this. The 2/3 power, that's the same as the cube root of 8 squared. So 2 squared is 4. So this is 4c. And if we divide by 4, we find out that c is 1/2. And that means that our particular solution is going to be 1/2 x to the 2/3 power. And that's how that works. So, something I probably should have mentioned in the first video, guys, a differential equation is an equation that is involving derivatives. And that's what we're dealing with here in this case. All right, looks like all kinds of stuff here moved on me. Let's see if I can move it back so it at least looks the way it's supposed to. So we got the E, and then let's see, you can move that. That was supposed to go up there. Okay, so hopefully that makes a little bit more sense because that work got a little jumbled. Okay, again, guys, that's how we find the equation is the same thing as finding the particular solution. All right, if we go ahead and we take a look at number 5, we want to find the particular solution. dy over dx is equal to y squared over x cubed, and y of 1 equals 2. Pause the video, see what you come up with. All right. So again, guys, what we are going to do is start by getting the y's and dy's on the left and the x's and dx's on the right. So that's going to give us 1 over y squared dy equal to 1 over x cubed dx. What I would caution you about here a little bit is you've got 1 over y squared, 1 over x cubed. When you integrate, that's not going to give you natural log, okay? So that's one thing I would keep in mind. So what I would do before I integrate is rewrite this as y to the negative 2 dy equals x to the negative 3rd dx. Then I would go ahead and start to integrate this function. So when we integrate y to the negative 2, we're going to end up with y to the negative 1, and that's going to be times negative 1. So negative y to the negative 1 equals, and then x to the negative 3rd, if you add 1, becomes x to the negative 2nd, and we're going to multiply by negative 1/2 plus c. All right, so that's kind of where we're at this point. Now let's see what we can do to this. We could go ahead and move the negative over, and then y to the negative first can become 1 over y. This would become positive. This becomes 1 over 2x squared, and then plus c. Well, we don't know what c is yet. We want to get y out of the denominator if we're going to be able to solve that. Okay? So again, because we haven't figured out what c is, if 1 over y is 1 over 2x squared plus some constant, then y is going to equal 2x squared plus the constant. Again, because we have not decided on what that constant is. We want to then go ahead and find it by substituting in the point 1, 2. So 2 is equal to 2 times 1 squared. Whoops, put the parentheses in the wrong spot. Plus c. So c is equal to 0. And this is your general solution, but the particular solution would be y equals 2x squared. All right, guys, let's go ahead and take a look at the next example. All right, so here we want to find the particular solution. If y of 1 is equal to negative 4 and dy dt is equal to 3t squared over y. So even though we're dealing with different variables, you're still going to do it the same way as if this was dx dy, or dy dx, excuse me, where we want the y's on the left and the x's on the right. So as you go through, pause the video, give it a shot on your own, and then check out what we do. All right, so in this case, we're going to move the y over, so this will give us y dy and then 3t squared dt. All right, so that was pretty easy. Essentially, we're just cross multiplying to make that happen. All right, now we can go ahead and integrate both sides. So if we integrate y, we're going to get 1/2 y squared. And on this side, if we integrate 3t squared, we are going to get t cubed plus c. All right, so you can think about a few things right here. Get that 1/2 over. So y squared is going to be equal to 2t cubed plus c. Now, you might be thinking, okay, well, we're multiplying by 2, so why doesn't c become 2c? As that's basically because we have not decided what c is. We have not evaluated c. So these c's are different, all right, but it's still just going to be some constant value. Now, that right there could be considered our general solution. What we need to do at this point is we do need to figure out what is c. And this isn't a bad time to do it. So let's go ahead and plug in what we know based on over here. So we have, let's see, we can plug in -4 quantity squared is equal to 2 times 1 cubed plus c. And -4 quantity squared, that's 16. 1 cubed is 1 times 2 is 2. And then if we subtract 2, we find out that c is equal to 14. And then what we end up with is y squared is equal to 2t cubed plus 14. And then if we wanted to isolate y, we would square root both sides. All right, and one of the things that you might remember from algebra, hopefully you remember from algebra, is that when you solve an equation by square rooting, you're really going to get plus or minus the square root of 2t cubed plus 14. All right, but in this case, we want to find the particular solution that is going to satisfy this condition. And the fact that our y value is negative tells us that we want the negative solution. So because of that, our answer is just negative square root of 2t cubed plus 14. So up here, this could be considered your general solution. And then right here, this is the particular solution. All right, guys, that does it for the first, or for part 2. The extra practice problems, we will, I'll go ahead and post those in a separate video, but I'm not going to do them right here. So I'm going to end the notes right here. If you do want to check out the extra practice problems, look for the third video that'll have those in them. All right, guys, take care.